So for this experiment called Powerful Paper Pillars, you're going to need some paper to make some pillars out of. So I'm going to use A4 paper. This is what I'd like you to do for this one. So A4 paper, ordinary sheet size paper, okay? You're going to need some things to use as weights. And as you can see, I'm going to use this for part of it, and I've got these big packs of paper that I'll also be using, but obviously you're going to see just for a minute what I need you to do. You're going to need some sticky tape. I'm using paper tape, what some people call masking tape, because it's just easy to tear with my fingers, okay? But you can use ordinary sticky tape. What I want you to do is make a tube, say like this one. I've already made one, and I've got a few here. You'll see what they're for in a minute. So I've made one here, okay? Now I've made it quite a wide tube. It's a bit wider than, say, the tube on most kitchen rolls, okay? This particular one. So make it so it's a bit wider than the tube that you'd get, a cardboard tube you get inside a kitchen roll, okay? But I want to make one more, so let me make one more, okay? So just to show you, before you start rolling it, get your sticky tape. So you need, I'm using 2 bits on these, so I'm going to pull it off there. I'm going to stick it just on the edge of my table, and I'll reach for that in a minute. Okay, I'll leave that there. So I roll up my tube and handle the paper carefully. When you're making your tubes, don't scrunch the paper in any way, okay? If you can avoid it, please. Just roll it up carefully, so take your time, okay? So that's about right. Gently tap it on a flat surface, just gently to make sure it's nice and level on the top. This is how you make all the tubes I've just done. Okay, nice and gently, check it both sides, and get your sticky tape and make sure it stays rolled up. Okay, so that'll do for that one, and then the other one, oops, reach there for that one. Okay, so I think you'll agree, not terribly complicated. And notice I haven't put any creases or crumpled it up in any way. First thing I want you to do is to take your tube, move that there, lay it on its side, choose a weight. Now I'm going to use this plastic box. You could, if you've got a plastic box like that, that's great. Other things you could use would be maybe a paperback book. That'd be worth thinking about, because it's about the same size. You don't want something too big, so a paperback book is great actually for a small paperback like this, but something about this sort of size and shape, and something that's flat and fairly strong like that. Maybe cardboard, but a book is good because it doesn't bend too much. What I want you to do is just rest it on your tube, or even just put it straight on there and let go and see what happens to the tube, okay? That's the first thing I want you to do. Okay, now we'll finish with this for the moment. Obviously I'm not going to say what happens, I'll come back to that in a minute, so we'll get rid of that just for a second. Then what I want you to do is have another tube made ready, and I've already made 2 already. Try making the same size as each other, best you can. So this tube is about the same size as the one I just used. Now I'm going to stand it on end. Now remember, it was actually made of the same size piece of paper as well, so in terms of fair testing we've used the same material. Now actually I will actually use the same weight as I used before, because I think that's also keeping it fair, isn't it? So use the same weight actually, and this time balance it on top. Now when I'm looking from the side, it's easier for me to look right over the top, right there, and I want to balance it so that comes up into the middle. So I'm going to look over and there and see if you can balance it on, okay? Now assuming you can, actually, I'm going to do this one. Boom, boom, boom. Interesting. Now try, if you've got some more little weights you can put on top, see how many more you can pile on before it all collapses, okay? Once you've done that, and noticing what happens, the next part of the experiment is a bit more interesting. So first, you see what happens when you lay this weight on your tube, then you turn your get a new tube, turn it up that way, and use the same weight, put it on, and see how many more you can balance on it and pile up before it all collapses, okay? Once you've done that, the next bit is interesting, because here you see I've made 4 identical tubes. Well, not exactly identical, but they look quite similar. The weights I'm going to use are these, okay? You don't need to use this. This is big reams of paper. You may not have this to hand. If you're going to do this somewhere where you don't have paper, what I suggest you do, 2 things first. Don't do this on a table, okay? I'm doing it on a table so you can see what's going on. I recommend the floor, but you do want a floor that's nice and flat and smooth, so carpet floor is not good for this. If you've only got a carpeted floor, that's okay, and what I suggest you do is get a food tray. So a tray you might have put plates on the things, and just lay that on the floor, because that'll be nice and flat, and then put everything on top of the food tray, okay? Now I'm just going to lay that there, because this is the same size as the paper in here. And what I want you to do is whatever thing you're using, supposing you're using another food tray, something straight, because you may not have this, whatever you're going to put on top, what you're going to see me do, it's got to be something flat and rigid that doesn't bend. Now these, they do bend a bit, but not much, and these are pretty rigid. So you could actually use a hardback book, a big hardback book, and that'd be okay. But if you don't want to use that, use another tray. So if you're on the floor already, with a tray underneath, say on the carpet, you can just put a tray on top. Watch what I mean. Okay, so make your legs. Another name for these would be pillars. And there you can see where the name of the experiment is coming from. So there's the legs or pillars. And I want you to get one weight. Let's say you're just using a tray initially or a hardback book, and lay them as carefully and slowly as you can on top until you let go and see what happens. And assuming it's still there, I want you to see how many more weights you can pile up onto your one. Off you go. So what did you find out? Well, I'm going to show you what happened for me. That's the first tube which I actually made in front of you. Okay, so I'm going to lay that there. There's the weight I said I wanted you to use, something like this. And when we laid on top, probably you could have predicted this, it will squash the tube a little bit. If I turn it round, you can probably see that a bit better. If I lift it up again, move that slightly aside, watch again, I lay the weight on and it squashed it a bit. If I put it there, it squashes it even more. So it's definitely squashed it quite nicely. And of course, this isn't very heavy. This is just an empty video box. We've still got a video, goodness me. But if you're using something slightly heavier, I think you'll agree it will squash it even more. It might have even flattened it right down, mightn't it? So, I think you could have predicted that anyway. So that's what we did there. Let's get rid of that bit. Now, let's try this one. Remember, we made this one as my second one. And I said to you, and I already did this in front of you anyway, same piece of paper, sort of paper I made it from, exactly the same size tube pretty much, same weight, and doesn't seem to have any problem supporting it that way up. And of course, I haven't got any more weights to put on this now, so I'm wondering how many more you could put on. Of course, how much you can get on depends on how much each thing weighs. But when I did it, I got to about 4 kilograms of weight before the paper actually buckled and cracked down. I'll show you what happens, the sort of thing you might have seen happen. Be careful if it just falls over, of course, that just means it's lost balance. You don't want it doing that, you'll have to start again. So the sort of thing you would see happening, I'm going to simulate this, I'm just going to press harder. The sort of thing that probably would happen is that, and it'll fall, your bits will fall off to the side, and you'll end up with a piece of paper that's got some sort of crinkling and wrinkling on it like that, okay? Now I'm going to keep this piece because I want to talk about it a bit later, so I'm just going to leave it just onto the side there. And I'm not going to use that anymore because I've finished with that. Now, remember the second part of the experiment. I put the tubes here. This is my base because it's about the same size as that. I can see easily where I need to place my 4 tubes, okay? So I wonder how you got on with this one. This is my favourite bit, if I'm honest with you. This is really good. And 4. First weight. Now, of course, you may have used a tray, remember, which wouldn't probably weigh as much as this, but you may have had a ream of paper, I don't know. And I'm going to lay that on. Of course, I've got to come close, so I'm going to look carefully, see how I'm getting on here. I've got to see what I'm doing. It's important you lay it on slowly and carefully and just check that everything's in place. But so far, seems to be holding it up, no problem. Let's try 2. Now remember, there's 500 sheets of paper in that pack. A ream of paper is 500 sheets. Here we are, another 500. So 1,000 sheets of paper. See what happens. No problem. How about another one? Another 500. 1,500 sheets of paper. Let's try it. No problem. By the way, of course, I could talk about the weight of each one. The reason I'm not going to is because the weight of this pack of 500 sheets will depend on how thick each sheet is. Okay, and of course you may use 500 sheets of paper which is a bit thicker and a bit thinner. Not so much how thick it is actually, it's how dense the paper is, how much a little bit of that paper would weigh. And some paper weighs more than others, so I'm not going to talk about the weight. I'm just showing you in science what we might call a quantitative difference, the quantity we're using rather than actual numbers. Another 500. 2,000 sheets. What's going to happen, we wonders? No problem. No more to use. I wonder how many more you can pile on. I'm actually going to leave that one slightly open for you to find out yourself, because all I will tell you is you can go a lot higher. But I'll leave it at that. Remember, do this on the floor, because eventually they will fall off. Sooner or later, of course, it will be too heavy. Okay? And one of those columns at least will do something like that, and the whole thing will collapse. Okay, you don't want that on a table. Not only might it damage your table, more importantly, it might damage you, because it might bounce off on your foot, which isn't much fun. I can tell you, it's happened to me before. So what I recommend is you definitely do it with the heavy weights on the floor, and you stand well back, and if it does actually collapse, you can just step out of the way easily. I've done this loads of times with people where they do it on the floor. Nobody's ever been crushed yet. So remember, the other thing you saw me do, I put things on slowly and carefully, didn't I? I just lowered them on. I didn't suddenly dump them on. I did it slowly and carefully. But either way, it's pretty remarkable the amount of weight you can keep on just 4 sheets of paper. What's going on? So, how come? Well, think about it. When I had that one, and I rested a weight on the side, I'm just going to hold this here. Let's pretend my hand is the table there, and I just put the object on top and squashed it, and it changed shape, didn't it? If I hold it towards you like that, it squashed it down, didn't it? Or let's turn the other end around, you can see that better. It squashed it. And that's because all the forces were acting in that way, going towards the bottom and the middle of the tube, and squashed it down, okay? So all the forces, or most of the forces from my squashing force, was acting on a tiny part of the tube, pushing downwards towards the middle. And it's not strong that way, and it just collapsed. As you can see, it's doing a pretty good job that way up. And of course, if I had all those 2,000 sheets of paper packed on one of those tubes sideways, or even all 4, they'd all be flattened to the table by now. That's hugely heavy compared to them. But they're doing a pretty good job, aren't they? And I've already told you, or hinted, you can get a lot more of this than this on. So how come? Well, now think of it. You can see the tube is that way. So now all the forces that would have been squashing this one, if it was that way around, they're acting going down the sides of the tube. And one way of thinking about this is to think about all the forces that were concentrating just on one top edge and squashing it flat, are now being shared out around the tube and all down the walls of the tube. So now all the forces are travelling down the tube that way and being shared out and spread out around the whole tube. And in that way, the tube, of course, is a lot stronger, as you can see. Problem is, of course, sooner or later, you will have too much weight, even there. Now, although we can't see, there will be tiny little bumps and folds or gentle bends in there that you can't really see. But with so much weight, even the slightest little fold or bend that you can't even see will suddenly get exaggerated, and the forces will start acting in a different direction. While they're all acting perfectly straight down the sides, or as near as they can here, it will keep the weight there. But eventually, the way you might put it on, you might put a bit more weight one side than the other, but something will happen, and you won't even be able to measure it because it's so tiny, that will suddenly put a little bit more force in one place, acting in a slightly different direction, and a little crease will appear. And once one appears, that's it, the whole lot will go, and you'll just get a massive collapse, and everything will crumble to the floor like this. Okay? Amazing stuff. Okay, let's think of some variables. Well, of course, I've hinted at the variables so far with the weight. Keep going. What about the tubes themselves? Well, of course, these tubes were made from just one sheet of paper rolled up into a tube, as you saw. Of course, how about using more than one piece of paper, like 2 roll up together, to make similar sizes, but 2 sheets rolled together, or 3, or however many you want. I wonder if you could support more weight, or the same, or will it not be so good? What about if we change the thickness of these tubes? These tubes are probably slightly thinner than the tube you get inside a kitchen roll. Remember the one I did right at the start was a bit fatter, wasn't it? A bit wider. So I wonder if that's important. If I got 4 tubes like the ones I made right at the start, slightly wider, would they still work okay? Or do the tubes have to be thinner? That's something you can find out. What about the shape of the tube? If I turn that tube up and look through it, it'd be like a telescope, it'd be round, wouldn't it, around the outside, circular. I wonder if we change that in some way. One way of doing that, by the way, I'll show you really roughly with this one. One way is if you sort of squash the tube the one way, squash it the other way, and then you can open it up a bit so it's got more like a square shape on it. So a more square shape. I wonder if that would work just as well. And maybe you can think of a way of doing it where you get more triangular shape. What about the length of the tube? Because this tube, as you can see, this length, I rolled up that paper from a particular direction. What about if I use the same size piece of paper, keeping it a fair test, but rolled it up from the other way, so it'd actually be longer, because I rolled it up along its short edge. So I rolled it up the long edge, it'd be a longer tube, but it still worked. What about if you use very different lengths? What about if I used see, that's the size piece of paper I used, wasn't it, to make the tube, the one on the table here. What about if I cut it down the middle and rolled up that piece? It'd be quite a small, stumpy tube then, wouldn't it? Would that work, do you think? I'll leave you to figure out a few more things.